Okay, in problem set 6, partner A, we will be finding the area of a region with respect to x. So you have your two equations, y equals 0.5 x minus 2, and x equals y squared plus minus 8. So since we're finding the area with respect to x, we're going to have to make sure that both of our equations are with respect to x. This equation already is, so we're just going to leave it alone, but we're going to have to solve this equation to do that. So you're going to add 8 to both sides, and then find the square root of both sides, which will give you y equals plus or minus the square root of x plus 8. So those are your two equations. So the next thing you're going to do is you're going to plug them into your calculator and create a graph that should look like this. Then you'll find your different points of intersections for all your graphs. And if you see how this region is divided into two areas, that's because when we do our integrals, we'll have two different bottoms. See here, this region R's bottom is negative square root of x plus 8. But region S's bottom is 0.5 x minus 2. So what this means is that we're just going to have to use two integrals when solving for the area. Okay, so now we're going to set up our area function. So that's going to be the integral. So our first region is going to be region R. So that's going to be the integral from negative 8 to negative 1.211103, and our top equation is going to be the square root of x plus 8. Sorry about that, my dog had to go outside. So this is our top equation, and then we're going to subtract our bottom equation, which is going to be negative square root of x plus 8 dx. And then our second integral is going to be the region S. So that's going to be from negative 1.211103 to 13.211103. And our top equation is still going to be the same. It's still going to be the square root of x plus 8. But our bottom equation is going to be 0.5x minus 2 dx. So then the next thing we're going to do is we're going to simplify both of our integrals. So negative 8. So when you distribute this negative sign, that's going to make it a positive, and so this is going to turn into 2 square root of x plus 8 dx. And then same thing over here, you'll distribute the negative sign, and you'll get square root of x plus 8 minus 0.5x plus 2 dx, and that's from negative 1.2. Okay, so now that we have both of our equations, both of our integrals, we are going to solve. So I'm going to solve the region R integral first. So what you're going to use is you're going to use u substitution. Your u is going to be x plus 8, and when you find the derivative, you'll have du equals dx. So that means, just carry that through. So the area will be from 0 to 7.211103 of 2 times u to the 1/2, because you should know that the square root is the same thing as a 1/2 du. So when we find the integral of that, that gives us 4u to the 3/2 over 3, because you add 1 to 1/2 and then multiply it by its reciprocal, and that will be from 0 to 7.211103. Okay, so now that you have your equation, you're going to plug back in the x plus 8 and get 4x plus 8 to the 3 halves divided by 3 from negative 8 to negative 1.211103. And now we're going to work the next integral. So the first thing you're going to do is you're going to apply the sum rule. So you're going to separate all the different parts of the equation. So you'll have the integral from negative 1.21103 to 13.21103 of the square root of x plus 8 dx plus the integral of negative 1.21103 to 13.21103 of negative 0.5x dx plus the integral from negative 1.21103 to 13.21103 of 2 dx. So now that we have those, we are going to use u substitution to help us solve for this first integral. So u equals x plus 8, du equals dx. So that's going to give us the integral from 7.21103 to 21.21103 of u to the 1/2 power du plus the integral from negative 1.21103 to 13.21103 of negative 0.5x dx plus the integral from negative 1.21103 to 13.21103 of 2 dx. So now we're going to integrate all these equations. So that's going to give us 2u to the 3 halves over 3 from 7.21103 to 21.21103 plus negative x squared over 4 from negative 1.21103 to 13.21103 plus 2x from negative 1.21103 to 13.21103. So then we are going to plug back in our x that we had during our u substitution. And then we can just add the rest of the equations to that. And then the next thing we are going to do is we are going to use the fundamental theorem of calculus to solve for our answer. So for this first equation, so the area is going to equal 4 times negative 1.21103 plus 8 to the 3 halves divided by 3 minus 4 times negative 8 plus 8 to the 3 halves over 3. And now for the second part of our equation, or our second integral region, we're going to do 2 times 13.21103 to the 3 halves divided by 3 plus negative 13.211103 to the 3, squared, divided by 4 plus 2 times 13.211103, and then we are going to subtract 2 times negative 1.211103 to the 3 halves, divided by 3, plus negative 1.211103 squared, divided by 4, plus 2 times negative 1.211103 squared, not squared. And then you are going to plug all of that into your calculator, making sure to put all your parentheses in the right places. And what you'll get is the area equals, so from this part of the equation, you're going to get 23.585 minus 0, so that's 0, plus this part of the equation will give you 65.126 minus 43.633 plus 26.422 minus, and this part will give you 11.793 minus 0.367 minus 2.422. And when you add all of those up, you should get an area of 62.496.
Okay, in problem set 6, example B, we'll be teaching you how to solve for the area of a region with respect to y. So the two functions are y equals 0.5x minus 2 and x equals y squared minus 8. And in order to graph it, we want them both to be in y equals. So we're going to solve for y here. So add 8, and then we can take the square root of both sides. And so y equals plus or minus the square root of x plus 8. And so when we graph both of these, we get something that looks like this. And we're going to be solving according to y values because we're using sideways method. So there's just one region, and we're going to call it region R, and we have our intersection points. So the next step is going to be to get both of these in x equals format, because that's what we're going to do to solve the area with respect to y. So this one we already have, so I'm just going to rewrite it here. And then this one we have to solve for. So we're going to do y plus 2 equals 0.5x. And then here we're going to divide by 0.5, which is the same thing as multiplying the other side by 2. So we're going to have 2y plus 2 equals x, which when we distribute the 2, we get x equals 2y plus 4. And these are the two equations we're going to use in our integrals. So let's set up our integrals. So area is going to equal the integral from negative 2.605551 to 4.605551, because as you can see in the graph, when going from minimum y value to maximum y value, these are going to be our points. And we're going to do right minus left because it's sideways method. So we're going to have 2y plus 4 minus y squared minus 8 dy, because it's in terms of y, or in terms of x with respect to y. And then we're going to distribute the negative sign. So we're going to get area equals integral from the same points 2y plus 4 minus y squared plus 8, because we distribute the negative sign. And then we're going to put it in order of decreasing exponential value, just so that it makes it easier to integrate. So we're going to have negative y squared plus 2y plus 12 dy. Now we can use integration rules to find the integral. So we can just do it with normal exponent rules. So we're going to have area equals big F of x equals negative 1/3 y to the third, because we take that up by one exponent and then divide by 3, plus y squared, because when we bring that up to squared and divide by 2 we get 1, plus 12x, or 12y, sorry. And we're going to do that from negative 2.605551 to 4.605551. Now we're going to use fundamental theorem of calculus to solve. So it's going to be a big long equation, and it's going to look like negative 1/3, plug in 4.605551 to the third plus 4.605551 squared plus 12 times 4.605551. And we're going to subtract it by negative 1/3, negative 2.605551 cubed plus negative 2.605551 squared plus 12 times negative 2.605551. And when we put that all into our calculator, we're going to get it to equal 43.91478 minus negative 18.5814, and it's going to equal 62.496.